When a coal mine is closed and coal extraction has come to an end, it can still serve the local community in meaningful ways. Former coal mines also have significant potential as sources of clean, renewable energy. Researchers from the Netherlands, Poland, and Slovenia are investigating how 2 mines, scheduled to close within the next few years, can be given a second life as energy storage facilities and sources of heat. This research project, called GeoSolar, is funded by the EU Research Fund for Coal and Steel.
It is important to find new uses for the abandoned coal mines because they leave behind a substantial legacy, existing infrastructure, extensive mine lands, and a workforce with specialized skills. The underground caved area can be repurposed as heat storage media, and the mainland can host extensive solar installations.
The idea is to use the solar energy in the summertime to heat up the water, which we can then store in the subsurface in the abandoned coal mines. And then in wintertime, we can use that hot water to heat our homes.
2 mines were selected for this study: Velenje coal mine in northern Slovenia and Bolesław-Szmale coal mine in southern Poland. GeoSolar investigates the feasibility of this heat storage system. First, researchers from the Polish Central Mining Institute, GIG, and Velenje coal mine are mapping which underground mine workings and caved areas are suitable for heat storage. They are also examining water chemistry and ways to maintain water quality over time.
Bolesław-Szmale is the coal mine planned to be closed down soon, but excavation and shaft to be maintained will provide convenient access to mine water thermal energy system.
By examining both saline and fresh waters inflows and evaluating mine water chemistry, we are identifying the technical requirements for safe reuse and for future high-temperature thermal energy storage.
The rock properties and stability of the mine are also important. Do they effectively store heat? And do they offer sufficient stability?
We need to understand how the rock is going to respond to the continuous injection and extraction of fluids.
Here at the high pressure and temperature lab, we will perform experiments to characterize thermal hydromechanical properties of the rock. We will also study the operability, efficiency, and safety of the storage system.
The link between heat storage and solar energy systems and the heating systems in homes is being investigated by the Polish energy supplier Tauron and the Slovenian energy supplier Casena.
The proposing of coal mine Bolesław-Szmale would achieve annual green heat energy production of 160 gigawatts. Coupled thermal energy storage in closed mine would supply sufficient heat to local community over the year.
Coal mine Velenje is still an operating mine. We plan to shut down mine to the certain level where we currently have main transportation, ventilation, and all the logistics workings. This level would also represent a very accessible way to facilitate all the projects for the energy storage in the near future.
GeoSolar also involves local stakeholders to raise awareness of the potential for end-of-life coal mines to support a greener economy, bringing benefits to stakeholders, communities, and mining regions in transition. Repurposing mining infrastructure for clean energy is one promising pathway for post-closure management. Once the concept has been proven feasible, GeoSolar will explore how existing post-mining infrastructure can be adapted for this system.
If this project is successful, it would propose a post-closure transition strategy and business plan for end-of-life underground coal mines in the EU through repurposing, maintaining, and reusing of mine land, mine infrastructure, and underground space.
GeoSolar aims to lay down a solid base for a possible second life of mines as clean and renewable energy suppliers, a second life that is also embraced by local communities.